Hello, grade 9 learners. Welcome to today's mathematics lesson. My name is Rose Mtimunye, and this lesson is proudly brought to you by the Gauteng Department of Education. So today we are going to be starting an exciting section of geometry. We're going to be looking at the geometry of 2D shapes, and we are starting off with triangles. So today's lesson is literally just about understanding what an isosceles triangle looks like, an equilateral triangle, a scalene triangle, and also to understand what the interior angles of a triangle add up to. Okay, so today you are going to just need a pencil and a ruler for that. Okay, so make sure you've got those for drawing your shapes, and you'll need a calculator because we will be calculating interior angles. Don't forget to save our WhatsApp number 079 454 9535. Remember, you send us your pictures and you also send us your questions in text. All right, avoid using audio if possible, so that we are able to assist you while we are live. All right. So let's look at today's lesson objectives. By the end of this lesson, you should be able to define triangles in terms of their sides and angle and their angles as well, right? And we are going to be distinguishing between an equilateral triangle, an isosceles triangle, and a scalene triangle. Some things you need to remember include your types of triangles, your properties of triangles, as well as constructions. I hope you have had fun doing constructions in class as well. Right, so this is our baseline assessment. I'm just going to give you 2 minutes. You don't have to draw the shapes, you just have to give the meaning of what these shapes mean. All right, so you just write A and write the meaning, B and C, just write down the meanings of these shapes. You have 2 minutes. All right, how are you doing so far? Are you having fun? Are you now back and ready to continue with the lesson? All right, so all you had to do was to tell me what the angle indicated at B means. You had to show me what the arrows that are on the rectangle mean, as well as the lines on the rectangle on C. Okay, so the angle at B on your triangle is a right angle, so that is a symbol for a right angle. You find a little square or half a block indicated to represent a right angle, and if you still remember, right angle is equal to 90 degrees. Right, now when you have these types of arrows on your lines, these are there to symbolize parallel lines. Okay, and remember, when we write parallel lines mathematically, we use this symbol as well, right? So you use your railway track looking like symbol, right? But the two arrows mean that the lines with two arrows are parallel to each other, but they're not parallel to the line with one arrow. So what we mean by this is that AB is parallel to CD, but AB and CD are not parallel to AD and BC. Okay? And then for C, this one means that the lengths are the same, which means if it's 5 centimeters for AB, DC is also 5 centimeters, right? But they are not the same as AD and BC, which means AD and BC have their own length. Okay. All right. So I'll just give you 1 minute to quickly do your corrections there. I have another question we are going to add after this. So do leave some space for that as well. So you have 1 minute. Okay, so let's look at the next question. Next question, I just need you to tell me what we call these two triangles, okay? You're just writing down the names, so you have 1 minute to do that. Mhm. Right, welcome back, class. So for these two, you had to check the symbols that are on the sides. Now we know what these symbols mean, right? So with triangle, it tells you that all three sides are different from each other. They have different lengths, right? So this is a scalene triangle. Then for B, we have an isosceles triangle. It has two equal sides and two equal angles. Do you see that? Right. So just to remember an isosceles, you can always just think of two legs that are the same length, right? So here you can just have a quick 30 seconds to quickly do your corrections. Remember, I did say you don't have to draw the shapes. We are going to see them again. Okay. Right. So I'm going to give you 1 minute to find your rulers and your pens. Okay, so now you have your tools in front of you, right? You need to make sure you've got a ruler and a pencil in front of you for us to draw the shapes that we are going to discuss from now on. All right, so we first get into today's terminology. So these are some of the concepts you just need to understand, starting off with a triangle, right? So a triangle is a polygon, which means it's a shape with many sides that has 3 edges and 3 vertices, right? So it has 3 sides and 3 corners. It's as simple as that. So here I have an example of what a triangle looks like. This is a street sign. So you can look around the classroom and see if you recognize triangles. You should see triangles everywhere because triangles are part of most shapes that we have in life. Okay? Right. And then triangles have interior angles. So interior angles are angles that are found inside the shape, right? Here I have an example of what your interior angles would look like if you had a hanger. Right. So we are just trying to identify what interior angles should look like. All right. We are going to discuss this concept more closely related to geometry as we go through the lesson. All right. So have you found any triangles in your classroom? You should have identified a few items, right? Okay, cool. So we are going to start off by discussing triangles that are classified by their largest angle, right? So for us to classify triangles by their largest angle, we need to go back and remind ourselves of the different types of angles that we can come across. Starting off with an acute angle. Right, so an acute angle will be less than 90 degrees, right? And this is generally what your acute angle would look like. Obviously, it would face any direction, but it will not look like a right angle. Right, so you'd get a triangle that looks like this. If you notice, it has those same corners as our acute angle. And we would call this triangle what? An acute triangle. You can also call it an acute angled triangle. That's also fine. All right. Now, an acute angle triangle will have 3 acute angles, right? So that means you'll have 3 angles that are all less than 90 degrees. Just to remind yourself how to remember what we call those angles, think of small things. You know, when you think of a puppy, a baby, they are cute. See, a small puppy is cute, a baby is cute. So small things are acute. Okay. So that's basically how you can remind yourself that when you see this angle, it must look tiny and cute. Okay. Right. The next one, we are going to look at a right angle. Now, a right angle, we have seen an example in the baseline, right? So a right angle is equal to 90 degrees. And this is what a standard right angle looks like. Right, so this can be added into any shape, into a right angled triangle, it can be into a rectangle and all other shapes that we can find, right? So here we are going to be looking at a right triangle. You can also call it a right angled triangle. Okay, if you notice here, it's not the standard triangle that's facing to one direction, but you should be able to identify this type of triangle from any angle. Okay, it will have one right angle. Okay, that's the minimum condition for you to call it a right angled triangle. Most importantly, you should recognize right angles from any angle. That makes sense, right? So don't get used to just seeing 2 perpendicular lines that are facing the usual vertical and horizontal direction. Do train your eye to recognize a right angle triangle from any angle. All right. Now I have a question that I'm going to leave you with. You'll figure out the answers as we go through the lesson. Can you have more than one right angle in a triangle? Right. So you are going to think about this, ponder over it as we continue this lesson. At some point, I will ask you if you have an answer to that, okay? The next triangle we are going to look at is an obtuse angled triangle. So starting off by understanding an obtuse angle. So an obtuse angle will be between 90 degrees and 180 degrees. Okay, so that means this is what it would look like, almost like a deck chair by the beach or by the pool. Okay, and this is what your triangle would look like. This is an obtuse angled triangle, and remember, the minimum condition is that it must have at least one obtuse angle. Not just at least, it will have one obtuse angle. Okay, right. Why can't we have more than two obtuse angles on this triangle? The answer is actually related to the same question I asked you about the 90-degree angle as well. Right, so keep those two in mind. Right, a simple way to remind yourself of obtuse angles, think of a hanger. Right, the side or the vertex where your angle, your obtuse angle is the side where your hook for the hanger would be. Right, so when we look here, this is where my hanger would be, my angle would be, the obtuse angle. Right, I'm going to give you 1 minute to try and name these triangles, and then we are going to discuss them. All right, so do you have the names? Don't forget to send me those questions. All right, if you have any input about today's lesson, please do be in touch on 079 454 9535. 079 454 9535. By now, you should have this number saved. Right, you should save this number every day, 9 o'clock. Send us a good morning, right? Then send me a picture of your baseline, then a picture of your notes. Just be active. Let's participate. Let's see how you are doing. Okay. Right. So the first one has two equal sides and two angles that are equal. So this is an isosceles triangle. We saw it in the baseline. Right. So now what we're actually doing here is classifying our triangles according to their sides. Right. So we are looking at the sides that they have equal. The next one has all three equal sides. This is an equilateral triangle because it has three equal sides. Right. The next one is a scalene triangle. It's just going the other way, isn't it? Because there are no equal sides and there are no equal angles. Okay. So now we discuss their properties one more time. Okay. So here, an isosceles triangle will have two equal sides in length. Right. And then it will also have two equal angles, and these two equal angles will be opposite their equal sides. And with an equilateral triangle, you are going to have a triangle that has three equal sides or all have the same length, right? And the angles will also all be the same size. They'll all be equal to 60 degrees. Then we have a scalene triangle. Now, a scalene triangle, if you notice here, the sides have different lengths and also the angles have different lengths, sizes, right? So this is basically what you should know about your triangles, right? Remember, we started off with triangles according to their largest angle. We looked at an acute angled triangle. That triangle has all angles less than 60 degrees. Then we look at a right angle triangle that will have a 190-degree angle. Then we looked at an obtuse angled triangle, which will have one obtuse angle. Then we looked at these three according to their sides. An isosceles triangle, 2 equal sides. Equilateral triangle, 3 equal sides. Scalene, no equal sides. Okay, right, that's a quick summary. So now we are going to understand the interior angles of a triangle, right? Because we are using here an equilateral triangle because it's quite easy for us to be able to calculate those angles there. Remember, I said they are all equal to 60 degrees. So if we added 60 plus 60 plus 60, what should we get? 180 degrees, yes. So we usually will have our statement and our reason. We would say angle A plus angle B plus angle C will be equal to 180 degrees. And these are the 3 reasons you can use. Angle sum in a triangle. This is the reason I'm going to use for most of the lesson. And that is simply because you'll find that as you progress, this is the reason you use in your geometry, in your further grades. But all of these reasons are correct, okay? Or you can use sum of angles in a triangle, or you can use interior angles of a triangle. All of these are correct. You can use them. They are part of your exam guidelines as well. All right. You need to make sure you understand these reasons, because every time, remember I said in geometry all the time, when you make a statement, you must give a reason. Okay. So let's understand why we are saying angles of a triangle will add up to 180 degrees. Yes, with the previous example, we're looking at an equilateral triangle and we just assume that they'll all be 60 degrees. But let's understand why, right? So we are going to start with a simple triangle, no classification, it's just a triangle, okay? And then we are going to draw a line that is parallel to AB. So we're going to extend C upwards, right? Okay, now this is what your diagram will look like next. All right, so you just drew your quick triangle and then you add a line. All right, now from here, what's going to happen? We are going to look for your equal angles, right? Formed by parallel lines cut by a transversal. Do you still remember what that is? Right, remember your parallel lines, we're talking about fun, right? Corresponding angles, alternate angles, and co-interior angles. Yes, so this is where we are here. So now I need you to identify a pair that looks like that. Show me which angle is equal to which one. Okay, so if you notice, we have a Z here. I'll just draw a Z for you. Okay, this Z here is what type of angle? These are alternate angles, right? So it means that angle A is the same as that angle there, right? So those two, we can put an A again there because they are equal. All right, what other shape do we see? Do you see, let's try red. Do you see another shape? Do you see your F? This is your F. Your F is facing that way. So below the arms of the F, the angles there are equal. What do we call those angles? Corresponding angles, right? So, all right. So this is what we have so far. We have angle A alternating them, and then we have angle B as a corresponding angle with B that is inside the triangle. Now, do you notice something interesting here? What you should see is that we've managed to get all the angles of a triangle to be on a straight line. Basically, that's all that we've done there, right? So this is how we are able to prove that interior angles of a triangle add up to 180, because angles on a straight line are equal to 180. Okay, you don't have to keep redrawing. All of this would have been just on your first triangle, right? You are just trying to understand the process. Okay, all right. So I think you now have this. I am going to now move on to the next part. We need to actually apply the practical part of understanding the interior angles of a triangle, and we're starting off by calculating angle A. Now for us to calculate angle A here, we are going to add all three angles that are inside this triangle, right? So we'll say 65 degrees plus 90 degrees plus A will give us 180 degrees, right? Then we have to collect like terms. So when we collect like terms, we will say 90 degrees plus 65 degrees. Don't forget to give your reason. I will be using angle sum in a triangle all throughout the lesson. So we have 155 degrees plus A is equal to 180 degrees. Then you need to use your additive inverses. Do you still remember those? So you need to subtract 155 degrees on both sides. And you get A is equal to 25 degrees. Right. Okay. I would like for you to try calculating the angles A, B, and C here. So I'll give you 3 minutes to do that, and then we will move on. All right, welcome back, class. How are you doing with this work? This one was quite straightforward, right? The only difference is that there are no numbers at all. So you had to actually come up with the values, right? So A plus B plus C is equal to 180 degrees, and your reason will be angle sum in a triangle. And then, but because this is an equilateral triangle, A is equal to B and B is also equal to C. And this is just because these are interior angles of a equilateral triangle, right? So because now you know that these are angles of an equilateral triangle, you can divide 180 degrees by 3. And you get that angle A will be equal to 60 degrees, angle B will be 60 degrees, and also angle C will be 60 degrees. Well done if you got these correct. Okay, this is if you had to do the calculations. Most of the time you just state that A plus B plus C is equal to 180 degrees, and you'd say each of these angles A and B and C are equal to 60 degrees. Okay, right. Now I want us to discuss when the correct reasons for us to use when we are given equal lines in a triangle, and also when we are given equal angles in a triangle. Remember, the whole understanding behind being able to classify triangles is not for you to be able to just tell me the name of the triangle, but is to be able to use those properties to solve for the unknown. That makes sense? Okay, so it's very rare will you be told to classify the triangle. You find that it's only one question in an exam, and it was based on calculating an interior angle or an exterior angle. But you need to use that knowledge to find an unknown angle or an unknown side. So here we have, if HG is equal to HK, which two angles are equal? That is the question, right? When you look at your triangle, HG and HK are from the triangle GHK or HGK, right? You choose your letters and direction you want to use. So that means these are the two. What you do when you're told information like this, you put it on your paper or on your diagram, you add it to your diagram so that your diagram makes sense. So I've added my equal lines. Right. So when you see that, you are able to tell that means that the angles opposite these equal sides will be equal, right? So in that case, my angles will be the angle at G and also the angle at K there, right? So it means angle HGK will be equal to angle HKG, okay? And you see your reason. You say angles opposite equal sides. You need to learn that because we are no longer going to be using base angles of an isosceles triangle, okay? But if the isosceles triangle is upside down, do you get it? Right. So we are going to use angles opposite equal sides. All right. And then we have the next question. It says if KHG is equal to KJH. Are we looking at lines or angles here? It's actually angles. So we should be saying if K angle KHJ is equal to angle KJH, which one of these is the actual angle? It's the ones that have heads on them. Right. The letters that have heads, it's where the angle is. If those two are equal, which two lines will be equal? Have you identified the equal lines? Right, so your equal lines in this case, once you've identified the two angles, it should be quite easy because you just look for the lines opposite these angles, right? You look for the lines opposite these angles, and that will be HK and JK. And do you see the reason? You say these are sides that are opposite equal angles. So if you're given sides, your reason will be angles that are opposite equal sides. If you are given angles, you say your sides that are opposite equal angles. Okay? Right. So there we've indicated our two equal sides. Right. What type of triangle do we have here? Do you recognize this type of triangle? You should recognize this is an obtuse angled triangle, right? If you put your hook there, it looks like a hanger already, right? So with that, we are going to do some calculations. What will be our statement? It will be 15 plus 27 degrees plus A will give us 180 degrees. And the reason is the sum of angles in a triangle, right? So from here, I'd like for you to continue. You are going to give me the value of A. So I'll just give you 2 minutes to quickly continue and then we discuss it. Okay, how are you doing so far, class? So here we are going to add 15 and 27 degrees, and then we will subtract their sum from 180 degrees, right? So we'll have 15 plus 27 degrees gives us 42 degrees plus A, and we get A will be equal to 180 degrees minus 42 degrees. You see what we're doing here? We're just subtracting 42 degrees on both sides of our equation, right? Then you get A is equal to 138 degrees. Right. Now, you are able to tell that immediately you did your calculations correctly because you were expecting A to be bigger than 90 degrees but less than 180 degrees. So if you had gotten 42 degrees or 60 degrees, then you would have known that you did your calculations incorrectly because the other two angles are already acute angles. Therefore, A should have been an obtuse angle, okay? Right, I think you have that. Now, I'd like for us to try this activity. Remember, you're just going to make sure you are still giving your statement and your reason. For each of the following triangles, find the missing angle represented by a letter A, B, or C. Right, so for this activity, I want you to answer the first triangle first, okay? Find the value of A for 2 minutes. Let's do the solutions for that. Then we'll do the others as well. Right, welcome back. So I trust you were able to do the triangle that has angle A, right? Okay, don't forget, I'll give you time to do B and also C, okay? So for angle A, we are going to add 30 degrees plus 80 degrees plus A, and those three must give us 180 degrees. Now we know why they must give us 180 degrees, right? Then from there we have to collect our like terms. So we are going to add 30 degrees plus 80 degrees, and that gives you 110 degrees. Okay. Now looking at your triangle, you already have an expectation of a triangle that has of this angle being less than 90 degrees. Therefore, we can subtract 110 degrees on both sides and we get that A is 70 degrees. So what type of triangle is that? This is a acute angled triangle, right? So I'm just giving you 30 seconds while I'm on screen for you to quickly do your corrections. I know you got this one right. Maybe you just need to fix your reason and maybe show how you got 70 degrees, right? I trust you. So don't forget, when you are done with those corrections, do send me a picture. Let me see what your total is on 079 454 9535. So let me show you where you would get marks with this type of question, okay? You get a mark for having correct reason and correct statement. This changes with the grades. So later on, you find that if you have a statement and no reason, you won't get the mark. But here, if you have both the statement and the reason, is 2 marks, right? Then you get a mark for your calculations, the steps you used. So that can be a mark or 2. So for today, we'll have 1 mark for that. And then 1 mark for the actual value of the angle. Okay. All right. I think we all have those corrections. So now we are going to look at B. For B, I'm going to give you another 2 minutes to quickly do the solution, and then we'll discuss our answers. Welcome back, class. How are you doing so far? I hope you are enjoying the lesson so far. Don't forget to send me those questions on 079 454 9535. If I'm not getting questions, I take it you understand everything. And I'm very proud of you as a class. Okay. So here we are going to add 41 degrees, 54 degrees, and B. All right. And these three must give us 180 degrees. Your reason can be angle sum in a triangle, interior angles of a triangle, or sum of angles in a triangle. You can use any of the three reasons I showed you at the beginning. Then we collect our like terms. So we add 41 degrees and 54 degrees and we get 95 degrees. Then we have to subtract 95 degrees on both sides. So that means B will be equal to 85 degrees. Okay. Right. Remember, you still get your mark here. I hope you are doing your corrections. This is your time. You have 30 seconds. Okay. So you get your marks there. Another mark for this, the method you have used, and also a mark for your final solution. So far, remember there's 3 questions, so we are at 8 out of 12, right? Okay, so you will show me your total when you are done. Everybody has the solution? Right. Okay. We are now going to move on. The next one, you have to find the angle C. So you have 62 degrees and 34 degrees. What do you expect C to be? Do you expect it to be bigger than 90 degrees, bigger than 180 degrees? That would be a miracle, wouldn't it? And also, or are you just expecting it to be an acute angle as well? Right, so just ask yourself those questions and then answer this one. Another 2 minutes. Right. How is it going so far, class? I hope you are having as much fun as I am. So right now, all you have to do is to follow the same process again. Add all three angles and equate them to 180 degrees. And make sure you give your reason. Interior angles of a triangle, sum of angles in a triangle. Whichever reason you choose, make sure you use one of the three that I showed you. And then from there, you collect your lactums. So you're going to add 34 degrees and 62 degrees together. And that gives you 96 degrees, right? So now you need to find the additive inverse of 96 degrees. And this is positive, so it must be a negative one. Hence, we are subtracting 96 degrees on both sides. And then we get the value of C to be equal to 84 degrees. So this triangle actually has all three angles less than 90 degrees. So this means that this triangle is an acute angled triangle. You see that? Okay. We still get a mark for our statement, a mark for the reason, 1 mark for the calculations you've done, and a mark for your final answer. All right. Okay. So I think I've given you time to copy, right? 30 seconds, I'll just be on screen. Are you almost done? Right. Okay. Don't forget, you can send me your questions on 079-454-9535. Okay. So now I have another question for you. It says determine angle B. For this question, because it does require a few steps for you to take over, I am going to give you 3 minutes, right? You have 3 minutes to answer this question before we do the solution. All right, class. So how was this question for you? Because those ones were more like standard questions, right? These ones, how were they? Do you see what you have to do here? You actually have to apply your knowledge of the different types of triangles to solve this one, right? So we are going to start with identifying which angle are we looking for. So here we are actually looking for this angle, angle B, right? But in order for us to have angle B, because angle B is in triangle A, B, D, we also need this angle, angle D. We need the angle at D. All right. How do we find the angle at D? We actually need to use triangle ECD for us to get the angle at D. So if you notice, we've been given that 160 degrees there. So if we add the small angle there, ECD, those will be equal to 180 degrees. So we can say angle BCE plus angle DCE will be equal to 180 degrees. Okay. If you find that using the letters is a challenge, you are welcome to put numbers. Okay, you can put 1 and 2 next to the two angles and say angle C1 and angle C2 are equal to 180 degrees, and you make sure you give your reason as adjacent angles on a straight line. All right. Then from there, you now have to find the size of angle DCE, and angle DCE is equal to 20 degrees, right? So you're going to say 160 degrees for BCE plus DCE is equal to 180 degrees. Then you subtract 160 degrees on both sides, and your value will be 20 degrees. Okay, now you have 20 degrees. What do you do with that? Because you're actually just looking for angle D, right? So what you do from here is to actually pay attention to the fact that you've been given an isosceles triangle, which means that angle C is equal to angle CD, angle DCE is equal to angle CDE. All right. Okay, so those two are equal, and our reason will be angles opposite equal sides. Remember I said we pay attention to whether we're given angles or sides. So that means that the angle we are looking for is also 20 degrees. Okay, so now we know what the angle at D is, right? Okay, what do we do with that information now? I want to just give you 1 minute, just 1 minute to quickly do your corrections for this part, because I am going to move on to the next slide to continue with the solution. Okay, class. So we are running a bit out of time, so I am going to move a bit quicker for us to get to the rest of our solution. So we've identified that angle D is equal to 20 degrees, but we were asked to actually find angle B. Now, angle B is in triangle ABD, which is a right-angled triangle. So what we can do is to add angle A plus angle B plus angle D, and they'll give us 180 degrees. Your reason, angle sum in a triangle, interior angles of a triangle, you can use any of the three. Then you add 90 degrees and 20 degrees plus angle B will be equal to 180 degrees. You collect your like terms and then you subtract 110 degrees on the left hand side and on the right hand side. Therefore, angle B will be equal to 70 degrees. All right. Okay, just before I go, I hope you all have been able to follow that. I'll just be on screen for 30 seconds quickly. So we are very close to the end of our lesson. So if you still have a question, just quickly send it on 079 454 9535. Just to give you a guide, a question like this would be out of 5 marks because getting B is the last step. There's so many steps that you need to take. You'd find that for finding the angle at ECD, you'd get a mark. Finding the angle at D, you get a mark. And then coming back to find angle B would give you a mark as well. Okay? Right. This is your homework, a question from a past paper. So I'd like for you to try this question. So just take a quick picture, snap, a quick picture while I'm on screen. This is a question you're going to practice. Notice it's out of 4 marks. Make sure the answer has enough steps for you to get 4 marks. Okay? Right, so those who have it, please do share with those who still need to get this question. Right, if you're watching it on your tablet, you can just take a screenshot. Okay. Right, we currently haven't received any questions, but if you do have a question, you can quickly send it on 079 454 9535. All right. Now I'm going to look at our summary. Remember we discussed triangles by equal sides, and that would be an equilateral triangle, an isosceles triangle, as well as a scalene triangle. So an equilateral triangle will have equal sides and equal angles. All the angles will be equal to 60 degrees. An isosceles triangle will have two equal sides, and the angles opposite those equal sides will be equal. A scalene triangle will have sides that have different lengths and also angles that have different lengths, right? And then we also looked at triangles by their largest angle. So an acute angle triangle will have three acute angles. So all three angles will be less than 90 degrees. A right angle triangle will have one right angle. And I hope after we did our investigation, you understand why we have one right angle. Because your angles of your interior angles of a triangle add up to 180. You need three angles to add up to 180. But if you have two 90-degree angles, that shape will no longer be a triangle because it will have a sum of interior angles more than 180 degrees. It's the same concept also with your obtuse angle triangle. You cannot have two obtuse angles in a triangle simply because that shape would no longer have an interior, a sum of 180 degrees for your interior angle. Okay, right. Then the one theorem we discussed today was the triangle sum theorem, right, where we did discuss that interior angles of a triangle will add up to 180 degrees. In the next lesson, we are going to be looking at your exterior angle of a triangle. We are going to do a short investigation. Please, please, please bring your math set and also make sure you've got a protractor in that set. You need a ruler and a lot of paper for your drawings. Okay, so make sure you've got those for next week's lesson. Thank you so much for joining us today. This lesson is proudly brought to you by the Gauteng Department of Education. Please do stay safe and I'll see you in the next lesson.